So we just saw when we have more than two populations, right, and we're comparing the population mean, we need to do an overall test called the ANOVA test. Details are forthcoming, I promise you. But before we get there, why do we call it ANOVA? Why is it analysis of variance when we're talking about the population mean? Um, so here's the idea, okay? Here's why we want to call it the um, and why we call it analysis of variance. So overall, we have some normally distributed normal distribution of some characteristic. Okay, in our previous video we talked about height, right? So maybe it is height, maybe it's IQ. I don't know, but we have some big normal distribution. Okay, but then what we do is we then group this data according to different populations. Okay, so let's do population 1, um, population 2, and so on to population K. I don't know how much K is, but it's some number of populations. Okay, and these are grouped based on some categorical variable. Okay, and our previous one, it was race, right? Okay, so our populations are defined according to categorical variable. Okay, and so what we want to do is we want to compare the means, right? So what do? We have to get an SRS. Okay, we get an SRS from each of these. We get a simple random sample. Okay, we do a good sampling method, bottom line. Okay, and then from this SRS, we can get, sample mean for each of these, and then that might be our first point of analysis. As we look at the sample means, we're like, oh, they're kind of wonky. They're different from one another. Okay, we should do an ANOVA test. We should see, how different they are. Okay, now, and so what we want to do is we want to um, be able to compare these means to make an inference about the population, right? That's the overall goal of statistics. Okay, how do we do that? Well, the whole thing is that um, when we compare them, there is variability present. Okay, there's variability present in actually two different places. Okay, first, if we look at if we take the focus of a single population. Okay, so I'm just going to look now within, say, population 1. Okay, we know previously if we had just one population, depending on our SRS, that SRS can look different because based on who is selected, right? So there's some inherent variability present in here. So there's variability present in here. Okay, we need to account for that. Okay, now that's within a single population, but we all, of course, have multiple populations. Okay, so we need to be able to compare and account for the variability between the groups too. Okay, between the different populations. Okay, so somehow our test needs to analyze the natural variability present within a population as well as between populations. And that's where our statistical method gets a little bit more involved. Okay, so to properly do this, it is intense. Okay, we're going to simplify the process greatly in as much as go into Excel, click a few buttons, and you get your result. Okay, knowing that the actual calculations can be quite cumbersome. Okay, so the ANOVA test, it is an analysis of variance, but it's not variance in terms of like sigma squared. It's variance due to variability within a population, right? That is the one over here, and variability between populations. Okay, so we're going to see how to do this coming up here soon.